Recording. Okay, so I'll start right at the central core point or argument that I would try to express and explore during our workshop. And that central point is that everything that we do involves our eyes. And it's easy to relate to that statement when you think about movement. Any movement that you do, it's easy to understand how our eyes are involved as our eyes are such a are the dominant sense, but not so the central point that I'm going to try to make is that even thinking is a sort of movement, that paying attention to ourselves is a type of movement, that directing our consciousness towards a specific part, or what some like to call conscious access, right? You have a zillion things going around you when you walk or drive your car or whatever you do, but you're thinking about a particular thing or you're paying attention to a particular thing, and it can be external as well as internal. A thought, an association, a sensation from your body, a visual, whatever. You're thinking about what happened yesterday or what's going to happen today or tomorrow. So you have conscious access to those thoughts. That's where you're putting your mind into at that particular moment. And of course, that can change very, very, very fast, right? It can change every second or millisecond. Your mind wanders, your attention moves from one detail to another. Your eyes are involved also in all of those actions. So not just paying attention to details in the outside world, which is so visually oriented, but even how you do all the actions that are related to introspection, all the actions that are related to paying attention to yourself internally. They are all involving your eyes. And not only that they involve your eyes, they involve your eyes in a habitual way. So the way that we pay attention to ourselves, and it's not only the way that we pay attention to ourselves, it's even broader than that. It's the way that we sense ourselves. What 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 is being Raz, or what is being yourself, even that is habitual in many, many ways, and the eyes are involved in that as well. And why is that important? Because anything that we would try or wish to change or improve involves our paying attention to a particular detail, right? So I feel like my hip, my right hip is not swinging as fluidly as my left hip. I'm paying attention to that sensation. And that paying attention to the sensation, I'm doing something habitually with my whole self, which means that the involvement of my eyes down to the muscular level of how I organize my eyes is also habitual. And I might have amazing strategies of how to improve the swinging of my right hip. I might have brilliant ideas of what to do with myself to sense it more or equalize it, and whatever I want to do. I might find myself not really being able to change because the way I'm paying attention to those differences, even though I come with the best intentions to my left hip and to my right hip, not being judgmental, taking the time, using all this incredible Feldenkrais intelligence that I've accumulated for the past 20 years, still, I might find myself in a loop just because how I pay attention and how my eyes are involved in directing my attention to those sensations. So it can be related to pain, People notice their pain, sense their pain, perceive their pain with, I might say, a visual component that involves how they look towards the pain. Even though you're not seeing the pain, it's there behind me, right? I had a client who said, why should I even look at it? So rude of it, it's attacking me from behind, right? But that was, in fact, he expressed his habitual way of paying attention to the pain and his habitual um, attitude towards the pain that actually embodies a visual perception. He used those words, why should I look at it, right? When it's attacking me from behind, behind has a directional orientation to it. Um, so whatever we're going to do, it might improve your vision, although this is not a Feldenkrais for improving your vision workshop. Whatever we're going to do, it might improve the way you sense your eyes, although it's not a Feldenkrais for your eyes sort of workshop. And it's flattering to me that sometimes students join my workshop, and by the questions that they ask, it's evident that they did not read the workshop title and description. So it's flattering because they're coming for me and not for the content, but it's important that, so in the workshop content, I explicitly talked and related to this idea that we're going to work with the eyes in order for us to improve our own self-knowledge, knowing ourselves and understanding our self-image and the way we habitually use ourselves, and how the eyes are a central component in that habitual use, in that habitual self-image, and that they can be a powerful catalyzer, maybe a powerful, I don't know, we can find nice words and analogies to describe how involving the eyes or working with the eyes can be a powerful way to introduce change or improvement. So this was like the meta of the meta of the meta of the thing. Now I want us to go into some details, and we're gonna go super back in time. Let me share my screen with you so you can see my presentation. So everything that I'm showing you in the presentation today is super, super accessible through YouTube. If you go into YouTube, maybe not today, but during your free time, and you just type the evolution of the eye, the first videos, animations, the first animated videos, which are pretty short, 3, 4, 5, 6, 7 minute video animations, are just stunning. And I highly recommend that you do that after what we do today. Or okay, so in the beginning there was light and darkness. But in the beginning, life evolved in such a way that there were just these, single-celled organisms floating around in the sea. And their relationship to the environment, and this is 800 million years ago, more or less, right? We won't get stuck with the numbers, but around 800 million years ago, the way that single-celled organisms interacted with their environment was always through the membrane of the cell. The membrane of the cell is where you have a contact interface with your environment. But before there was vision or even light detection, what could you possibly sense about your environment through your membrane that comes in contact with your environment? So you can detect heat, right? You can detect gradients of minerals and salts. You can detect, maybe you can detect motion because the waves, it was all in the sea at the beginning, the waves are moving you. So maybe there are sensory motion sensors in the membrane. But this is before there were real teleceptors, anything that could give you information of something in your environment that does not come in direct contact with your membrane. Okay, because heat is the temperature of the water that comes in contact with the membrane. With whatever gradients or the concentration of salt comes directly in contact with the membrane. And the first sort of teleceptor that could tell you something about your environment that does not come in direct contact with you is light. Light sensitive proteins, which have been there for 800 million years or even more, and are abundant in plants and animals throughout all of the what do you call it, phylum of the the animal and the living kingdom, which are of course not simple, but these are proteins that sit in the membrane of the cell, and they respond to light. We're not going to go a lot into it, but that's how vision, the basis of vision is that in the membrane of the cell, there's a protein that reacts to light. Um, and what does that give you? So if you imagine that this blue area is an area on the membrane of a single celled organism, and it has a lot of these proteins. It's a cluster of these proteins that are sensitive to light. What does that give you? It only gives that single-celled organism the ability to know if there's light or if there isn't any light. It cannot tell the direction of the light because the light also passes through the other side of the membrane, of the other side of the cell. The membrane is transparent, so it doesn't know if it's coming from the front or from the back, or from the right or from the side, but it knows that there is light. A major advantage for such single-celled organisms was the ability to know when there's too much light, because UV radiation could be very, very harmful. So they could detect UV radiation, they could have night and day, right? Which is important, what they call circadian rhythm. But that's not vision yet. Oh, okay. So this is a blown up picture of a membrane, the membrane. This is the cell membrane. The gray area is the cell membrane. And of course, it's filled with proteins that detect all sorts of things. And this is the protein that is light sensitive. It's made of opsin, which is a name of a protein. There are many, many, many types of opsins, but opsin is the light sensitive protein across the entire evolution. And within it, there's retinol, which is a derivative of vitamin A. That's why eating carrot is good for your eyes. So the retinol responds to light. It bends when light hits it, and then it can rebend to its original position. But by bending, it changes something in the opsin. The opsin runs a cascade in the cell membrane. We're not going to go into it, but that creates a response in the cell. But you can't know where light is coming from, right? So the next step was to put, so again, this green square is a patch of these light sensitive proteins. But if you just put a patch of light sensitive proteins, they only know light or dark. Now you want to know directionality. You want to know where the light is coming from. So all you have to do is put some pigment behind the patch. So light cannot come from behind the patch. It can only come from those directions where there is no pigment. And that's very, pigments are there, algae have pigments, plants, like the most ancient microorganisms had pigments. This is not a very, it's easy to find. You go into any supermarket, you have a shelf full of pigments, you take a can of your favorite pigment, you stick it behind a protein sensitive patch, and you have directionality. Not very good directionality, but you know front from back, you can know up and down. So now you already have something that's related to your orientation in space, because you can know, oh, light is coming from above and below is the surface of the sea, so it's darker there. If you need more light, oh, that's up, that's down. Those are the most basic directions of orientation. What's the next slide? Oh, great. And this is not a theoretical thing. There are actually single-celled organisms. I can't remember its name. I took it out, so I don't have to deal with remembering its name. Single-celled organisms that actually have the brown area is pigment. The light spot is a cluster of these light-sensitive proteins. And the tail, it's not a tail, it's called the cilia. It's like a hair, but it's all part of one single-celled organism. That light is connected to the cilia, so this single-cell organism can already navigate itself and move in relation to whether it detects light or doesn't detect light. Now, the advantage over a single-celled organism that doesn't have this mechanism is extraordinary, just extraordinary, because you can move away from harmful UV light, you can move towards heat or away from cold, you can move in, if you're living, whatever, you can choose where you want to live, right? Otherwise, you're just flowing with the waves. You have no control, hardly any control, hardly any decision making. Of course, this is not decision making as we think of decision, not that we have a lot of decision making, let's admit to that. I mean, we all know that even our decision making is very limited. But of course, it's not a cognitive decision making, but it's a survival decision making that's giving this single-celled organism a huge, huge, huge advantage. Okay, so now we're skipping to a multi-celled organism, but we'll see that the principle stays the same. So what happens in a multi-celled organism? That particular cells are designated for particular functions, right? In a single-celled organism, he has different, like, not organs, but organelles that are dedicated to energy metabolism, or like here, light detection, or the cilia that is a motor component. Multi-celled organisms have cells that are designated for specific actions. So this is the basic visual unit in a multi-celled organism, where you have the pigment in a cell, right? So now there are cells that are designated to creating pigment. So light doesn't come from all 360 degrees. It comes from particular angles. And you have cells that are dedicated for having an enormous amount of these light sensitive proteins. So this is the cell that is responsible for sensing light. And this is the pigment cell that is responsible for not allowing the light to come from behind, but only from in front or from the sides. Oops. Yeah, it's another picture of the same idea. So this is like a light sensing unit created by two cells. Now, the photoreceptor, it has all these folds in the membrane, so it can stack up more and more and more of these protein sensitive cells. So in our photoreceptors in the eye, we have in each photoreceptor, at least in the rods, I read it today and I remembered the number, although I don't like memorizing numbers, but in the rod, which is a type of one of the two types of photoreceptors we have in our eye, there are 10 million of these light-sensitive proteins in one cell, and we have millions of those cells in each eye. Yeah, good. So this again, it illustrates the same visual, but this is already a visual motor unit because it, oops, let me just, this is a sort of a very, very primitive, basic visual motor unit where you have a photoreceptor, light sensitive. You have pigment that blocks the light from coming from that direction, and it's connected to a cilia, to a cell that has cilia, that the cilia are like tails that are movable. So that's the motor unit. So this is very, very, very primitive. This is 700 million years old. Okay, so these are, so we're jumping forward in evolution for a moment to see the two types of photoreceptors that we have in our eyes, the rods and the cons. We'll talk about them later. But if you can see here, all these folded discs are in the rods and in the cons, and all these little, the lamellar, no, not the well, anyway, these discs, these folded discs are actually the membrane folded onto itself so it can have an abundance of these light sensitive proteins. Okay, so how do you increase, if you have a unit of one photoreceptor and one cell that creates pigments, you're still very primitive. So why not just increase the numbers of photoreceptors? That's a good idea. And increase the foldings in the membrane. The more foldings in the membrane, the more light sensitive you are, and the more photoreceptors, again, the more light sensitive you are. But in this configuration, you still cannot detect where the light is coming from. If the light is coming from the right, it's going to shine on all three photoreceptors. It's coming from the front, it's going to shine on all three photoreceptors. It's coming from the left, it's going to shine on all three photoreceptors. Only if it's coming from the back, it's going to be blocked by the pigments, right? So still not really vision, more just light sensitivity. But, and this is the unbelievable, one of the unbelievable things, that if all those photoreceptors are clustered, but then they're folded backwards into a pit, right? Into a hole, then the light that comes from the right or from the front or from the left is going to stimulate different photoreceptors. Not all the photoreceptors are going to be stimulated. So now you actually have directionality, okay? Which is really the basics of, yeah. So this is another good example of if the light shines from a particular direction, it's going to stimulate, it's going to shine on a particular photoreceptor or a cluster of photoreceptors and not on the entire, all of the entire patch of photoreceptors. And of course, once you have directionality, you need more computational power. So this comes with a more developed nervous system. And if you have a more developed nervous system and you have the ability to detect light in a more defined way, you can produce behaviors that are even more and more visually based, right? Or yeah, behaviors that are visually based, or that they rely upon vision to be executed. And believe it or not, the eye of a flatworm is just that. These are the photoreceptors. All those, it's not hairs, it's the folded membrane that is packed with protein-sensitive light, protein light sensitivity, or yeah. And um, these are still the pigments, the cells, or the pigmented cells that were lying behind the photoreceptors are creating this pit, and light comes from the front. the eye of a flatworm. And, you know, I don't know if this is 100% accurate. I didn't do this. I took it from YouTube, of course, but the people who did this, or the presentation from who I took this, is somebody who studies the evolution of eyes for the past 40 years. I saw a video of him doing a presentation when he looks like he's in his 60s, and I found one when he looks like he is in his early 30s. So that's what that man has been doing his entire life. So I guess this is pretty accurate, and this is the resolution that a flatworm would see. And that's a lot of information. If you think about the dark places and the light places, and if it wants to escape from predators under the rocks, or anyway, very, 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 very useful to have this abundance of visual information. Okay, we'll continue later. So now we're going to do an ATM. Okay, so get your space ready. We'll take like a minute and a half before we start, so you can organize your space. Try to um, aim your camera as best you can towards your mat, so I can see you. And we're going to do a lesson. It's going to be on the back and on the side, but we will start in standing. We'll take another minute before we. Okay, so come standing up. Good. Now, it's important that you stand in such an orientation that, and you'll see why I'm asking of you this, that you stand in such an orientation that you don't have more light to the right of you than to the left of you. So if you have a light source, stand either with your back to the light source or with your face to the light source, but not with your side to the light source. Okay, so that when you close your eyes, you wouldn't feel like there's more brightness on the right or on the left due to the orientation, your orientation to the light source. Okay, good. Now just stand there for a minute. If you can stand with your eyes closed, if closing your eyes gives you uncomfort or interferes with your balance in some way, you might want to stand behind a chair so that putting a finger or putting your hands on the chair would give you stability so you can be with your eyes closed. Good. And now, as you're standing, sensing yourself, see if you can think about the line of the horizon. The horizon in front of you, beyond the walls of the room, obviously. So as if though maybe you're standing on the top of a hill on a small island looking towards the sea, so you can look at the horizon in front of you. But just imagine that line of the horizon. And now imagine that if you were really to stand on this hill, on this little island, if you were to turn around yourself 360 degrees, you don't have to turn, but if you were to turn around yourself 360 degrees, you would continuously see the horizon. So imagine this line of the horizon circling around you like a big, big ring, as if though the line of the horizon is a huge ring from the front to the sides, behind you, all 360 degrees. And notice, what do you do with your eyes when you're thinking about this, this ring of the horizon, this line of the horizon that circles you 360 degrees? Right. Good. Now, very gently, just think about the left quadrant of the horizon, meaning the horizon, the line of the horizon, or that part of the ring that is in front of you, and then that goes out to the left. Just of that left forward quadrant of the ring. Of course, you can move a little bit if you need to, but it's mostly like in your mind's eye. But notice, is it really just in your mind's eye, thinking about this left quadrant? Or is it actually in your eye? And is it in your left eye or in your right eye? Is one eye doing something more dominant when thinking about the left quadrant? And of course, the best way to know is to compare it with the right quadrant. So a few times, think about the right quadrant of the line of the horizon, or that horizon ring. And notice, is it clear as the left quadrant, or is it different? Is it the same eye thinking about the right quadrant, or did you switch eyes? Good. Now, as you think about the right quadrant, see if you can even think about the right posterior quadrant, meaning the quarter of the circle of the horizon that is behind you. So you're thinking about the entire half ring to the right, from the front to the back. And notice, are you straining your eyes? Even though your eyes are closed, and unfortunately, you're not on an island surrounded by ocean. But are you straining your eyes? Is it really just in your mind's eye, or are you really doing something with your eyes? Good, and now switch back to the left forward quadrant. And think about that entire left half of the ring of the horizon from the front to the back. And notice, is it different? Is one half clearer than the other? Is one half somehow connected to your eye in a more direct, maybe potent sort of way? That's right. Now think about, again, the left forward quadrant. So just the left, just in front of you and a little bit to the left. And then again about the right forward quadrant in front of you and a little bit to the right. And can you sense, can you choose? If you were, okay, I'll put it this way. Of course, if you need to take a few steps, if you're getting tired from standing, take a few steps whenever you need to. Without knowing anything about your eyes, if you have a difference between one eye or the other, you have spectacles, prescription, whatever, if you did not know anything, if you deleted your information of what you know about your eyes, could you feel just from this small experiment that one eye is somehow more dominant or clearer in your perception. Just by thinking about the left quadrant, or the line of the horizon from the center to the left, and from the line of the horizon from the center to the right. And you're going to need to choose the leading eye. We'll call it the leading and the following. So, not to be judgmental, dominant and not dominant, bad or good. We're going to call it leading eye and following eye. Okay? So you have a leading eye. Once you have a leading eye, you can lie on the floor. And if you're not sure, just pick one, but try to remember those differences. Ah, Snunit, sei qui. Non ti ho visto entrare. Okay, so take a moment to just sense yourself lying on your back. And, throughout the ATM, whenever that you feel that it's too much for you, I really encourage you to rest as much as you need, even though we're going to do very simple things in a way. For some people, they might be intense. And I think all ATMs are really, their benefit comes from doing them a few times. So please be gentle with yourself and with your expectations and with your, ambition to do the lesson right. Good. And now bring your hands in front of you, your arms in front of you towards the ceiling. That's right. And fold your fingers, leaving your thumb in the like position. So your fingers are folded, not into a strong fist, but folded towards your palm, but your fingers are staying not exactly upright, but not folded towards your palm. And erect both hands so that the nail part of your thumbs is directed towards your eyes, right? So if you were to open your eyes, you see the nails of your thumbs. Okay, good. But have your eyes closed. Have your eyes closed. And just feel the relationship between your left thumb and the center of your eye, of your left eye, and your right thumb and the center of your right eye. And do you remember which eye you chose as the leading eye? Is there a better connection in a way, or a clearer connection between that leading eye and your thumb? Right, so you might want to bring one arm down and just to sense the thumb in front of one eye, and then maybe switch. But maybe switching would get you more confused. Maybe you do need to do it with both hands in front of you and just move your attention from the line connecting your left thumb and left eye, and then the line connecting your right thumb and your right eye. Imaginary line, of course. Okay. Good. And bring both arms down beside you. And now cover your following eye. Oh, Valeria, sei qui. Ciao. So you're covering your following eye with your hand. So your hand is like cupped on your eye without pressing into your eyeball, leaving your leading eye exposed. It's closed. I mean, the eyelids are closed, but the eye is exposed. And you bring the thumb of the leading eye in front of your eye. Again, your hand in the like position, the thumbs up position, although the thumb is not really up, it's more oriented again in that way that the nail of your thumb, the dorsal part of your thumb is directed towards the center of your eye. And just stay there for a moment and feel where do you need to position? How do you know where to position your hand in space? Your hand is straight forward. Your elbow is straight forward. How do you know where to position your hand in space so that the thumb is in front of your eye? Now, don't try to be intelligent about it. Don't try to be intelligent and don't try to fix anything, but just very, very, very slowly. From this position of your thumb being in front of the center of your eye, start lowering your thumb very, very, very slowly. Super, super, super slow. Very, very, very slow. It's going to take you, I don't know, 60 seconds, maybe even more. Slower, 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 but don't fix anything. Just lower your thumb in a vertical line, and the vertical line from which the thumb, the original position of the thumb you started with, lowering it slowly, slowly, even slower, slower. You shouldn't be past halfway to the middle of your eye. Slowly, 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 slowly. And notice, do you know where the middle of your eye is? Do you know where your thumb is? Slowly, slowly. Take even more and more time. And you will see that a funny thing happens, that the slower you do it, the more somehow it feels off. Until eventually you might find yourself touching your eye or your face, and notice that you touch the middle of your eye. How much of a discrepancy is there between what you think you're doing and what you're actually doing? Good. Excellent. And bring your hands down by your sides. Rest for a moment. And cover your following eye again. So your leading eye stays not open because your eyelids are closed, but it stays exposed. And bring your thumb in front of you once more, but this time have your thumb touching your eyebrow. So with your thumb touch your eyebrow, the eyebrow of the leading eye, and with the direction of the growth of the hair of your eyebrow, slide with your thumb on your eyebrow to the side, to the corner of your eye, below your eye on the upper part of your cheek, towards the bridge of your nose, touching yourself for real, not in the air. So this time your thumb is really touching your face, and you're sliding with the tip of your nail on your thumb and around your eye, right? So you're not pressing on into your eye, you're on the bones, you're on the orbit surrounding your eye, but you're doing a very small, very slow circle, sliding with the tip of your thumb. Go ahead and notice, are you straining your left eye as you're doing it? And gradually increase the circumference of the circle, very gradually. So you will always be coming back to the bridge of your nose, but instead of sliding on the eyebrow, slide a little bit above the eyebrow on your forehead, and a little bit more towards your temple, and a little bit lower on your cheek. And each circle that you do, so you're like drawing a spiral on the left, not the left, on that side, sorry, I was doing it on the left, on that side of the face of the leading eye. We're so habituated to using right and left teaching ATM. All right, and you draw each time a larger and larger circle. So after a few times, you'll find yourself reaching your hairline on your forehead, the side of your temple, down on your cheek, maybe even reaching your lips, going up on your nose. That's right, and do it slow enough so you'll be able to feel how that leading eye is being engaged. Are you just sensing the movement and what you're doing with your thumb on your face only through the tactile and kinesthetic sensations, perceptions? Or is there actually something visual in what you're doing? Are you actually seeing, even though your eyes are closed, seeing something of this circle, of the direction of it, of the trajectory, of its orientation? And again, are you seeing it in your mind's eye? Or is this leading eye actually following? Is there something actually in the gaze of using that eye that is involved? Good. And bring both hands down. And now roll to lie on the side of the following eye. Can't use right and left. Giving myself a challenge. Good. And have your knees bent comfortably at 90 degrees. Great. And now slowly roll your head and your shoulders. Roll them backwards so you can have your face oriented towards the ceiling. But your knees are still 90 degrees, one on top of the other. They don't have to be glued on top of the other. They can disconnect if they need to. Cover your following eye. And lift your arm in front of you so that you have your thumb in this like position in front of the leading eye that is pointing towards the ceiling. Good. Now first, without looking at it, just feel, is your thumb in front of the middle of your eye? Or is your hand inclined up or down or to the right or to the left? Good. And now from this position, do something very simple. Roll yourself just a little bit, even further towards your back, just a little bit. You can allow your upper knee to disconnect from the lower knee. Rolling your pelvis a little bit backwards, taking your hip back, but keeping your thumb and your eye really, really together. So your head would roll a little bit with your chest, with your pelvis, with the lifting of the knee, as your hand moves a little bit further to the back, just a little bit. So your starting position is being with your face to the ceiling. So you're already twisted. And from that position, you don't have to twist even more. You just roll yourself a little bit backwards, but don't come lying on your back. So your knees stay on the side. The upper knee would lift a little bit as you roll backwards a little bit, and you come back. You come back not to the side, but you come back to having your face and your hand and your thumb and your leading eye pointing forward towards the ceiling. That's right. So you're doing a very simple movement. You're just rolling a little bit backwards, but moving in such a way that you can feel that your thumb and your eye, as if though there's a line connecting them, and that line doesn't get separated or broken or bent. So that they maintain, your thumb and your eye maintain a consistent relationship. Maybe a fixed, but I don't want to use the word fixed because then, fixed has its connotations. That's right. So you're not rolling your head and moving your arm, you're rolling your entire self. So your eye and your hand move together because you're rolling your entire self like a cylinder. Good. And lie on your side, rest on your side, on this side that you're already lying on, but not in the twisted position. Just rest on your side for a moment. And whenever you're ready, turn yourself again so you're facing the ceiling, covering the following eye, putting your thumb, the thumb of the leading eye, putting it in front of you again, putting it in front of you. And again, roll yourself a little bit backwards, back and forth, keeping your eye and your thumb together. That's right. Good. And then every time you return, every time you come back, leave your hand, leave your thumb in the turned position so that you return with your whole self and your head and your eye, but not with your arm. Your arm stays more open out to the side. So it's no longer in front of your eye. So your eye comes back to the original position, facing the ceiling, but your thumb, your entire arm, you keep it opened out a little bit to the side. That's right. And then when you roll backwards again, your eye rejoins your thumb. And when you come back a little bit towards the side, Your eye moves with your head, with your torso, but it disconnects from the thumb. You do that a few times. Good. Now, every time you return and your hand stays out to the side, keep looking at it with your leading eye, even though your eye is closed. Fix the gaze of your leading eye on the thumb as you return a little bit towards the side and as you roll a little bit backwards. So your leading eye is fixed on the thumb that is opened out a little bit to the side. Great. Now move everything together again. Your thumb and your eye and your torso and your pelvis. Just the simplest from facing forward towards the ceiling, a little bit out to the side, and return. Everything together and your thumb in front of your eye. Fantastic. And come lie on your back again and rest for a moment. I'm going to notice the sensation on the side of the face and around the eye itself of that side that was following your thumb. Of course, comparing it to the side that was covered. Good. And slowly come lie again on the same side. But this time have your lower leg straight down. So you have only the upper leg bent in front of you. That's right. And again, turn your head and shoulders into the twisted position. Of course, your knee, the bent knee, can be lifted off the floor, hanging in the air if you need to roll your pelvis, so you can find yourself facing the ceiling comfortably, covering your following eye with its respective hand, holding your following thumb in front of the following eye. And of course, both eyes are closed. And do the same thing here. Just keep yourself right as you are. You're perfect as you are, and just roll yourself a little bit backwards. Allow your knee to lift a little bit. Your hand, your arm that is forward in front of you would move backwards a little bit. Your shoulder, that shoulder would come a little bit towards the floor. You're rolling your head also with that hand that is covering the eye. It's also participating in the movement. So you're rolling your entire self in such a way that you don't need to coordinate your hand and eye connection. All you need to do is roll yourself a little bit backwards. Right? And notice if your thumb stays in front of your eye. If that connection between the middle of your eye and your thumb, is it clear? Or is it somehow something that you need to strain yourself in order to sense? And when you're trying to sense it, even though it's an imaginary line, are you working with that eye? Good. And then again, keep your arm open out to the side to that new position after you've turned, and say your arm moved 15 degrees out to the side. Keep it there and continue the rolling of your entire self, but just your hand and arm and your thumb are staying in that new open position. So they're not vertical towards the ceiling, they're a little bit off to the side. That's right. And every time you roll backwards again, your eye rejoins your thumb. But when you roll a little bit back onto your side, your eye disconnects from your thumb. And it can, as if though, look towards the ceiling that's in front of you again, and rejoins your thumb and disconnects from your thumb. That's right. And then every time you roll back onto your side a little bit, keep your eye looking at your thumb. So even though your torso and your head and your pelvis are rolling onto the side, your eye stays towards your thumb that is angled out in the opposite direction. That's right. But do it slow enough, so you're not straining the eye. And just by thinking of your thumb, just by keeping your attention, or your what we call conscious access, that you have that position of the thumb constant in your awareness, would direct your leading eye as if though it's looking at it. Great. And come back to lying on your back and rest there for a moment. So in a way, the first thing that we want to be able to observe with ourselves, at least in these types of lessons, is if are we in fact straining our eyes even though they're closed and there's nothing to see, even though it's in our mind's eye, or actually maybe not really in our mind's eye, but really in our eye. And even though we have these conditions where it's not really difficult to track, right? So we're doing like a tracking sort of movement, the eye tracking the movement of the thumb, but it's actually very simple because it's the entire body is rolling in a unified way. So the action of tracking should be very, very simple. And nevertheless, the first thing that we want to observe, and most of, I think it's pretty rare to not sense it, that we're straining our eye as if though we're really trying to see something that is difficult to see, right? Which just shows how much our vision is involved in non-visual tasks, and how much non-visual tasks are actually visual. Right? Because you can say, oh, your eyes are closed, it's a non-visual task. Really? Are you sure it's a non-visual task? come lie on your following side again. Same side that you were before. And have your knees bent at 90 degrees again. And turn yourself so you're looking towards the ceiling. You're in that twisted position, your face towards the ceiling. But this time, cover your following eye with your leading thumb. That's right. So you need to take the thumb that was in front of the leading eye. That hand is now covering the following eye. So you're crossing the midline of your face and covering the following eye. Okay, and you can have your elbow really close to your chest. You don't want your elbow high up in the air, because with your other hand, you want to lift your arm forward in front of you and cross your arms in such a way that the other thumb would be in front of the leading eye. That's right. Good. And now take everything backwards again. Roll yourself a little bit backwards, keeping the thumb of the contralateral side, keeping that thumb in front of the leading eye. Trying to sense, are they really moving together? Right? It's as if though you're tracking the movement of your thumb. But really it's not the arm that's moving the arm, it's the entire rolling. So it should be fairly easy to track because your head and your eyes are moving in space in a very similar way to how you roll your entire torso. And yet, are you straining yourself mentally, visually, muscularly in this eye? And just feel if that training is necessary. Is there a way to gently roll, moving the thumb and the eye and your entire self together in a way that doesn't strain the muscles around the eye, doesn't strain, it engages your visual systems but doesn't strain them. So it becomes easy. It becomes very simple. Maybe not today. Maybe you need to do this lesson. I personally found the simplicity increasing every time I did more and more, day by day. I did not have the simplicity I wished to have the first time I did it. I mostly had the sensation of superfluous efforts and strains. That's right. Good. Come back to lie on your side. Rest on your side again. And twist yourself again so you're facing the ceiling. Cover your following eye the same way you just did with a contralateral hand, bringing the thumb of the other hand in front of the leading eye. Good. And now every time you roll, so roll backwards again a few times with your thumb and eye moving together with the rolling of your pelvis and your chest, very simply. It can be 10 degrees further out, further backwards and return. It doesn't have to be more than 10 degrees from the straight forward towards the ceiling. That's right. And then keep on doing it, but don't move your hand. Keep your hand in the vertical, in the original position. So your body is turning and twisting as if though away from your thumb. And your thumb doesn't move to the side with your head, with your eye. That's right. But as you do it, keep your eye looking towards your thumb. So as your head rolls, your eye is keeping its gaze, quote unquote, because it's closed. It's keeping its gaze on your thumb. And again, it should be very simple. You're just rolling your entire torso a little bit backwards, but keeping your thumb and eye directed forwards. What's the big deal? That's right, but just notice how many superfluous efforts are sneaking in. Right, and come lie on your back again and rest for a moment. And notice again the sensation between the eye and that side of that face of the eye that was covered compared to the leading eye. Perhaps a difference not only in the eye and in the face, perhaps a difference throughout the entire length of that side as opposed to the other side. Maybe even something in how you sense the space around you. To your right, in relation to how you sense the space around you to your left. And one last time, come lie on that same side. And turn your face and shoulders towards the ceiling. Cover the following eye with a contralateral hand, as we did a minute ago. So your leading eye is still exposed forward, and bring the thumb of that shoulder that you're lying on. Man, no right and left. Sheesh. And hold that thumb in front of your leading eye. And have your bottom legs straight down. So you have your entire side that you're lying on long. You could, of course, the knee that is bent could be lifted off the floor, like hanging in the air. That's right. And then in the twisted position, you're rolling yourself backwards a little bit. Could be 10, 15 degrees. Simple, simple. You're rolling yourself like a log, like a twisted log. Everything moves together. So it's easy to track the thumb. Everything moves together. Just make it nice and comfortable and simple. That's right. That's right. But I don't know if you've noticed, we've constantly went only to that quadrant. We've only explored that quadrant. So now as you turn backwards, keep your hand forward. Don't move the thumb with your eye. Keep your thumb forward towards the ceiling and keep on rolling a little bit backwards and return in the twisted position. You don't have to twist yourself more. You're just rolling yourself as one unit. The twist is already there. That's right. And as you turn backwards, keep your leading eye on the thumb. So your eye would move towards the inner corner of your eye as if though you're looking through the bridge of your nose towards that thumb that is in front of you. That's right. And then keep that relationship. Keep that relationship, and every time you return a little bit onto your side, move your thumb towards that. Oh my God, no right and left. Move your thumb toward, oopsie, how can I tell you where to move your thumb? So you're moving your thumb to the other quadrant of the horizon, the one that that you haven't explored yet. Every time you roll back onto your side, you move your hand and your thumb towards the other quadrant of the horizon. That's right. And you're looking at your thumb through the inner corner of your eye, of the leading eye. You're not really you can't even see it. Even if you had your eye open, you couldn't really see it because your nose is blocking and the hand that is covering your other eye is blocking your view. That's right. Good. And come back to lie on your back again and rest. Good. And bring the thumb of the leading eye in front and cover the following eye with your other hand and just hold it in front of you. And notice if something changed in how you perceive this thumb-eye relationship and how you see this imaginary line connecting the thumb to your eye. That's right. And now again, very, very, very slowly, start lowering the tip of your thumb. Start lowering it very slowly towards the middle of your eye. And just notice if, in a way, something is different. Maybe simpler, maybe more complex, maybe more detailed. And it's not like a test to see if now you're more accurate in bringing your thumb to touch the middle of your eye. It's just to see if your self-perception has changed in some way. Right. And bring both hands down to the sides. And just notice again The eye, the face, the entire length of the side of the leading eye. In relation to the other side that was covered, the eye of which that other side was covered. Right. Right. Now, slowly come up through your side up to sitting. And from sitting, slowly come up to standing. And when you reach the standing position, stand in the same orientation in the room with which you started. Remember, I said about the light being either from behind you or in front of you. That's right. And just take a moment to stand and notice your general sensation in standing, but in particular, the orientation and the sensation in your eyes, the orientation of your gaze, if you can be with your eyes closed. And now think again about that line of the horizon that's in front of you. And think of that line of the horizon circling you 360 degrees. Right, and then think about the left quadrant of this big ring from in front of you to the left a few times. And then the right quadrant, of course, you take your time to test and, where you direct your attention, you really navigate it according to your own sensations. But just notice if the leading eye is still the leading eye in how you sense the tracking of the line of the horizon, or did something change? That's right. Now, as you track, and you can do it from side to side or track just one half of the ring of the horizon and then the other half, as you track, turn your head just a little bit. So if you're tracking in your mind's eye the line of the horizon to the left of you, turn your head a little bit to the left, but see if you can think of that entire half ring of the line of the horizon all the way to behind to that part of the ring that is behind you. But you follow your thought, your intention, the line with a little bit of a turning of the head. We'll notice which eye is more leading in the gaze, even though they're closed, even though it's in your mind's eye. Right? And then try the other side, the other half of the ring. The eyes switch, or is it still the same eye that's leading? Good. Okay, and walk around a little bit. Open your eyes gradually, gently. And walk around the room. Notice how you carry yourself. Notice how you look at the room around you as you walk, or how you look at yourself, at your own sensations as you walk. Great. So we'll take a 2-minute break. I don't want you to sit in front of the computer right away. So take a 2-minute break if you need to drink or eat something. Okay, so take 2 minutes on your watch before you come back to sitting in front of the computer.
מבאס לשים משקפיים עכשיו, רז.
חייבת?
אם יש איזה מצגת אז כן.
אז תחכי רגע, תראי אם זה...
ממש לא בא לי לשים.
Okay. Okay. So, without straining your eyes, I'm going to share my screen again so we can go back to the PowerPoint presentation. And let's see. Yeah, so really this very, very fundamental idea that, and it's an interesting, so what they say in evolutionary biology about the evolution of the eyes is that even though not all living creatures developed eyes, eyes have developed independently in different lineages, independently from one another. I heard one guy say at least 40 times, right? So something about being able to detect where light is coming from, as we saw with a single cell organism, is such a huge advantage that photosensitivity or light detection evolved numerous times throughout evolution, independently of each other. And they actually have genetic ways to prove it. It's extraordinary. But it means that vision and light detection is even the most primitive light detection, as we see with a single cell organism that doesn't really know, it's not vision even yet because it cannot detect details. It just detects the intensity of the light and the direction from which it comes. That's it. And even in differentiating the direction, it's very, 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 very basic. It's just front or back. Is the light coming from in front of me or from behind me? That's it. But already that gave such an incredible advantage to being able to orient yourself in space and to be able to move in space and to give you more choices over the competing organisms that do not have light detection abilities, right? So really the driving force of being able to create more and more complex behaviors, in a way one can say vision is a central, I wouldn't say the only component, but is so central and fundamental that throughout evolution, it just kept evolving and evolving and evolving more and more. So let's see, yeah, maybe we should we see the next evolutionary? Yeah, why not? Okay, so we saw that this flatworm has a very simple visual system, but already by having this small pit in which the photoreceptors are moved away from the surface, it enables to detect where the light is coming from, not only front and back, but also right and left, because the directionality of the light would shine on different photoreceptors within the pit. But you see, the visual resolution is still not that good. So another way to improve the visual accuracy is to make the pit even deeper, build more or create more photoreceptors, and make the hole from which light comes into that pit even smaller. So that way, the directionality of the light is being, the resolution of where the light is coming from is even better, right? So if, say, let's go back to, yeah, let's say this would be, you know, a 3-pixel sort of picture, which is really, really, really low resolution, then this one would already be, I don't know, you can't count it by the photoreceptors, but by the whole accuracy, this would be 10 times more, if not even more. Now, the interesting thing is, or one of the interesting things is that the photoreceptors themselves are backwards to where the light enters. So we mostly feel our eyes, or if you think of yourself looking, your eyes looking, the image that you have of yourself, unless you have strain in your eyes, in which then you feel the muscles to the side of the eyeball or even behind the eyeball. But if you don't have strain in your eyes, the sensation of where your eye is in the front. It's where the eyelids touch your eye, right? It's where your fingertip would touch your eye, but that's not actually where your photoreceptors are. That's not where you're receiving visual input from. That's only the entrance. That's only where the light comes from. And in fact, yeah, the photoreceptors are much way deeper backwards posteriorly in relation to where you look in the mirror and you see the front of your eye and your eyelids and your iris, and right? That's not where visual perception starts, actually. So yeah, let's go back to this sort of eye. So this sort of eye, it resembles you know, a whole camera, where you take a camera and you put light sensitive photo paper, which hardly exists today anymore, and you create a really, really small hole in the front, and the light comes in from the hole and creates a blurry inverted image in the back of the camera, in the back of the box camera. And in fact, do I have a picture of, let me see. No, I don't have a picture of it. Okay. Yeah, so we'll save the next, no, maybe we'll go one more step. One more step to improving this sort of primitive eye. Okay, one way to improve this primitive eye is to create a lens at the front of the eye that would concentrate the light, that it can absorb a lot of light, and it would concentrate the light even in a more specific way on specific photoreceptors. So this is a primitive sort of lens, right? It's made up, they give the analogy that a water droplet can actually act as a lens. So if you have this sort of eye and this space is open without a lens, if you're able to make some sort of circular formation that even has just water in it, but is consistent, you already direct the light in a more centralized, focused way onto specific photoreceptors. And of course, with the course of evolution, you see there are more membrane foldings in the photoreceptors, so there's more protein-sensitive light, and the pit became even wider and deeper. And this sort of eye, which is not that primitive in relation to our eye, is the eyes that all snails and the entire phylum, or the entire family of to whom snails belong, they all have these sort of eyes that are already, box jellyfish. And you see the lens, photoreceptors behind, and the pigments. All these little dots are the pigments behind the cell, conforming to the same original architecture that we saw with a single-celled organism, right? Now, such a complexity would evolve only if it gave behavioral advantages in directing yourself in space, and in then being able to make decisions regarding where you want to be in space. So of course, all of this entire evolutionary course had to come with more computational power and a nervous system that becomes more and more developed. Yeah, so this is a little, I think this is a ragworm. And you see the eyes, still quite primitive, but part of what makes them primitive is that they're very, very, very small. So all he needs to do is enlarge those eyes. He'll have more photoreceptors. He'll be able to absorb more light. He'll have more depth perception, et cetera, et cetera. Yeah, so this is a simulation of the quality of the picture that a ragworm would see, right? But it would enable him to know when it's night and when it's day, and if he should hide behind a dark spot or he should go out into a lighter spot, and so on. Yeah. That's a box jellyfish having the same sort of eye, same architecture of the eye, which is different, of course, from ours, but it's getting there. It's in that direction. And this is what a box jellyfish would see if he was on a roller coaster, the upper picture. Right. Okay, I think that's enough with the eye evolution for today. We'll finish it off next time. So, yeah, good. I think it's a good timing for some Q&A. I think I've said my piece for the day, no? So just to remind you, you're all muted. So if anybody wants to say, share, ask. You need to unmute your microphone.
I'm curious whether the macula, is that take the place of the pigment you're talking about?
Mm-hmm.
As per Google, the macula is just one specific area of the retina. So all the qualities that the retina has with the cones and rods, but it's the trained area to be a lot more specific for the purpose of vision.
Right.
It's basically part of the retina as far as the structure, and then as for the well, it's interesting if we develop what neurological relationship we develop with this particular area for functional vision, but it's part of the retina.
Great, thank you, Iris. Yeah, and we'll go into the structure of the human retina probably later in the sessions. So we'll run up against the macula as well. Thank you for that clarification, Iris. Joyce?
So I was thinking that from this, the lesson was totally enjoyable, and I'm surprised how much I can as if see behind me now. So since my eyes aren't back there and literally seeing behind me, as much as the development of the eye is so interesting evolutionarily, but what was happening in parallel? Because clearly we have other mirror neurons. I mean, I'm not exactly sure what they're called, but other sensory systems, you know, other parts of the neurology that was developing in parallel that gives us these sensations. So I love that you're doing the eye, but now I'm wondering, well, okay, now what others, you know, what was happening in all the other systems at the same time?
What was happening in the nervous system during that evolutionary course?
Yeah, you know, how did it expand? So it was
Great.
Yeah.
So I'm sure there are great YouTube videos about that as well. So we have stuff. So we have stuff to do towards next week.
We have stuff to do.
Yeah, that's a fantastic question. Fantastic. Naoko?
Yeah, so with this line business, with this all ATM, with eye exercise, I always have a bit of a challenge because, you know, I mean, you draw a line, you know, between your finger or whatever with the pearls or whatever, you know, and then they say imagine it. So I'm I'm working very hard to I mean, imagine, and as a result, instead of focusing on the physical entity of the eye property, that I feel like I am using the acuity to create this line, you know, to create this line, the horizon, the quarter or whatever, you know.
Yeah.
So and then I tell myself like it's sensing, you know. So I don't need to actually clearly see these lines. But and then like this between the thumb and then the eye, it got more in the middle at the end, you know. So I am sensing, but it's different from looking at it, right? How would you say? I mean, and then I'm just like, I'm not seeing this line. But
yeah, I'm not going to answer that. I just think it's a great observation.
Yeah.
Yeah, because your eyes are closed. So are you trying to see the line? What does that mean, trying to see the line if your eyes are closed? And if you're not trying to see the line, you're trying to sense the line. How are you sensing the line? With which sensation are you trying to sense the line? Because you're not touching it. So it's not a tactile thing. Is it kinesthetic? But the line is in the, so what is it? Right? So
yeah,
that's part of the point that I'm trying to make of how it's all so interweaved and in a way inseparable. The real usage of the eyes with your thoughts and with what you're thinking about and your associations and your external environment. It's just one big pack that, of course, it's plastic and interchangeable, right? But it has a lot to do with, again, if we go back to habits, it would be interesting to try to see if what you're doing and trying to see the line is habitual in a way, that you're engaging yourself in a way, should I say it? In a way that reactivates habits of real vision, of really seeing, and thus creates superfluous efforts or parasitic efforts.
Mhm.
Right? That's part of that was.
Yeah, because it feels different between see it with the mind's eyes. That's like imagining it, you know. So my eyeballs might be looking at forward, but I'm imagining it, versus like look at it with your closed eyes are two different things. So,
Right.
you know.
Yeah.
Right.
The wonders of our brain.
That's what
Yeah.
it's all about. May I recommend the book to everyone, Roz?
Yeah,
Because
sure. Go ahead.
I don't have binocular vision. I only see out of one eye at a time. So I don't have, and I found this book several years ago called Fixing My Gaze by Susan Barry. And she was cross-eyed as a baby. And that gets into, and she is a neuroscientist, and she decided as a 40-year-old, I think, or when she was in her 40s, that she wanted to see if there was something she could do to regain stereoptic vision, which she had never had. She'd never seen the world three-dimensionally like me, and like many people. And she was successful, but she describes, in this book, she not only describes her own experience, but she describes in great detail, because she is a neuroscientist, the relationship of the brain and the eyes and vision. Even in blind people, you know, the visual cortex operates even if you can't literally see. So it's a fabulous book, certainly in the context of what we're doing here, and in terms of Feldenkrais and the relationship to movement, as you said at the beginning. She really explains it so clearly and beautifully. And then she describes very poetically her own experience of seeing three-dimensionally for the first time, going out and into a snowstorm and seeing the spaces between the snowflakes, which she had never experienced until she'd gone through this whole process. I just want to say about my own experience. I started out, I'm almost blind in my left eye, and for some reason I chose that as my leading eye. At the beginning, I was able to see the horizon more clearly to that side. But
how interesting.
Yeah, but at the end, I had lost it completely. When I stood up after the lesson, I couldn't find the horizon at all. It was gone. It was, at first it seemed to be floating a little bit above my head, and then it was gone. And I couldn't find it on either side at all. So.
Wow. Fascinating.
Fixing My Gaze by Susan Barry. And you said it's available as an ebook, Roz?
Yeah, I got it.
It's on Amazon.
Yeah.
Yeah. It's
I haven't read it yet. I just, yeah.
Yeah, it's really awesome. It's really, I highly recommend. You'll love it.
Great. Thank you, Madeline. Great.
Hi.
Anybody else?
If I love the lesson, if just to add to the clan of people who see in each eye separately, which I'm one of, this lesson, I could write poetry about the different sensation, the awareness that it brought into that, of the muscular control and the perception of each eye. So, which I'm sure that even people who have their vision focused with both eyes can tell, but how one eyeball actually sees the horizon lower and one eyeball sees the horizon higher. And Madeline, I was impressed with the fact that you chose the eye that you know that is not your leading eye, which make me want to do the lesson again, because my sensation in what I know is my leading eye, and it is my leading eye, was a lot more tense, like muscular tense, more like a contracted muscle type of a thing when I did all the instructions. And on my non-dominant, the one that I suppress and basically don't use on a regular basis every day, there was such a novice feeling of lightness, and it was physically a lot more pleasant to follow the instruction with the non-dominant eye. That was just like, the minute I switched to the eye that I use all the time, it was like this unnecessary effort. It's just like, but I'm so impressed. I would like to know what led you to pick that, what physical sensation or perception to pick that as the leading eye?
Because I really felt at the beginning when we were looking at the horizon and trying to follow it behind ourselves and so on, I surprised myself. I thought, oh, isn't that weird? This eye is the one, I use them both every day. This one I use for reading and for close-up things, and this one I use to see far away. And apparently when people have cataract surgery now, for some reason, doctors offer them the option of having their eyes reconfigured that way, which sounds completely crazy to me, why anyone would want that. But so I don't feel like I have one that's dominant and one that's non-dominant. They do different things. But for some reason, I surprised myself when I was looking at sensing the horizon in the beginning. It wasn't an intellectual thing. I didn't decide I was going to challenge myself by using that eye as it just popped out. Yeah, and I was surprised. So
great. I would
Iris for complimenting me on that choice. It was not really a choice.
I would highly recommend that you do this lesson again, or for everyone. This is not just for you, Madeline, of course, for everyone. I would highly recommend that you do this lesson again, or parts of it from your memory, or do it from the recording with the other eye. Tomorrow, or in 2 days, or in 3 days, right? And then I would highly recommend that you do the lesson again, or parts of it, but interchanging from the dominant to the following eye. Because first of all, in my experience, it really is a lesson that doing it just once, it's just, in a way, it's just to provoke the curiosity, really. I mean, I think there's so much in the lesson that one can get, not get, but the nuances in the sensation are not tangible within one go, right? You can't get them from one lesson. So repetition for this sort of lesson, I think, is really, really, really crucial. And of course, we did just one side to intensify the differences, to create more of a kinesthetic perceptual distinction, but then playing and comparing, okay, what happens if I do the same thing with the non-dominant eye? What happens if I interchange? I do it once on the right, once on the left, I cover this eye, that eye. I think you'll find, yeah.
Sorry, can you clarify the very last set of movements where you're moving the, I think
that was kind of complicated because I didn't have right and left at
but I had the feeling
at my disposal.
We were moving the arm that was covering the following eye toward the floor.
Yeah, so everything that we did, let's say this is my leading eye, not let's say. So this is my leading eye. Everything that we did on the side was turning towards that quadrant, right? With the thumb turning towards that quadrant, staying with the thumb in that quadrant, return again, and that everything was towards the quadrant of that leading eye. Towards the end, we switched, and really, really at the end, we did a combination of looking at the thumb with the leading eye, looking at it as the head is turned, but then rolling towards the opposite quadrant.
So you are rolling toward the floor.
Yeah, so forget the movement instructions, but just forget the movement instructions, just the principle that if I see the left quadrant of the horizon clear with my left eye, what am I going to do in the ATM? I'm just going to keep going into that quadrant in different variations. I'm going to keep going into that quadrant as the first strategy, right? And then eventually I would want to spill over into the opposite quadrant in some way that would I don't know, smartly spilling over into the opposite quadrant.
See what's over there, right?
Yeah.
Got
Yeah.
it.
So that was the basic strategy of the Allison. Go ahead.
So yeah, I found it interesting trying to determine my dominant eye. I chose my left, and when I went to the left, it actually was a harder side to go towards the horizon, but I felt like my right eye didn't help me at all. And when I went to the right, I felt like my left eye was really supporting that. So I thought that was my dominant. I don't really know, but it was interesting. At the end, I did notice that both my eyes did not have to move as much in order to see behind me, because before my eyes were moving a lot. And then also that when I got up and opened my eyes, I felt like I didn't have to reach out to see, like it could come to me, you know, that kind of thing. I felt some of that sensation. Yeah, which was really interesting and nice. That was nice. Yeah.
That's beautiful. And that's something that I hope we will continue to develop, because in a way, being so wired in our entire nervous system, being so wired into visual perception, right? And visual perception being as if though I'm seeking the world outside of me. So there's something very habitual. I don't want to ruin your own spontaneous, revelations, but still there's something very habitual in how we use our eyes that is over expressed in some sort of like a forward vector in our organization. Whereas in fact, I think it also has to do with this self-image that we are consciously aware of the front of our eyes, but that's only where the light comes in through. And again, the photoreceptors are actually right somewhere. So the eyeball is quite thick, right? So we're actually seeing not from the front of us, right? Or the neurological process of vision, the cascade that starts with light sensitive proteins, as we said, actually starts from deep inside our eyes. So this whole forward habitual self-perception driven tendency, or I don't know how to call it, is in a way a real distortion of what really happens, because light comes to us. We don't need to move towards the light. Light comes to us and it enters deep into our eye. There's nothing forward that we need to do. And in fact, when we'll look at the muscles, we'll also see that there's no muscle, there's no forward moving muscles in the eye, right? So great, fantastic. Good. Jan.
A couple of interesting observations for me. At the very end, when we brought our thumb back to our eye, my thumb seemed much larger. And I was fairly accurate on the first time bringing it. My thumb ended up slightly at the corner of my eye, and this time it was more accurate, but the size of it was much clearer. There were a few interesting moments during the lesson where I didn't know if my eyes were open or closed, which I've not experienced that before. That was interesting.
Wow.
And then at the very end, when we were scanning the horizon again and actually doing a little bit of turning with the head, both directions, regardless of what I thought my dominant eye was, it was the other eye. So if turning to the left, it was my right eye was the one that was dominant, turning, and similarly to the other side. So both of those eyes were more intense And there's a one ATM I've done it's an AY lesson. You're on your side and you're using one eye to turn your head towards the floor, and then you discover that the eye that's furthest away has a greater involvement.
Yeah, as the one leading you.
Yeah, so that it was very interesting to have the clarity on both sides, so it almost didn't matter what I thought my leading eye was.
Fantastic.
Turning better to both sides.
Fantastic. Great. Okay, great. I think we can end. I will